The ability of advanced driver assistance systems to detect objects has dramatically improved over the past few years. In fact, autonomous driving is considered to be 10 times safer than manual driving. However, even the most sophisticated object detection systems are prone to phantom attacks.
So phantom attacks are depthless projected objects which are being treated as real objects despite the fact that they are fake and depthless. And split-second phantom attacks is a split-second projection of an object, and this can be done using a digital billboard or a projector, which triggers an undesired reaction from an advanced driver assistance system or a semi-autonomous vehicle due to the fact that they are unable to distinguish between fake and real objects.
Ben Nassi and his research colleagues researched the impact of phantom attacks using a Tesla X, which has one of the most advanced driver assistance systems among autonomous vehicles.
Now, we found that the Tesla Model X responds or reacts in response to a projected pedestrian that we projected on the road. So basically, despite the fact that the pedestrian picture is depthless, Tesla treated it as a real person, and in some cases stopped the car completely. And in another case, we were able to trigger Tesla's autopilot to stop in the middle of the road in response to a stop sign that we added to a digital advertisement for 500 milliseconds and triggered the car to stop in the middle of the road in response to a compromised digital advertisement.
In order to prevent phantom attacks, Nassi and his colleagues utilized a committee of experts where a set of models is used to examine different aspects of an image.
So we suggested the use of a new neural network that we named Ghostbusters that intended to detect such phantoms and ghosts. And we trained it to distinguish between fake and real objects. And we did it by training it to detect the characteristics that we as humans associate with projections.
The embeddings of the four models were combined in a final ensemble layer, which is then used to compute the final analysis of whether an object is real or fake. So how effective was the Ghostbuster method? And even if it's effective, how efficient is it in terms of quickly processing all the data without restraining the system's resources?
We were able to reduce the success rate of the attack from 99% to 1% by integrating Ghostbuster model to the object detectors that were tested. It definitely can be deployed on commercial autonomous vehicles with negligible overhead in terms of the execution time, and it doesn't require a very strong computer to run it.
Learn more in the contributed article, Protecting Autonomous Cars from Phantom Attacks, in the April 2023 Communications of the ACM.